Help support our coverage with a free account on Privacy, the service that keeps you protected when shopping online. Get $5 to try it now by using promo code QZZ2J.
All right. So I'm assuming this is Magnus from from Acconeer. Did I pronounce that correctly? I'm sorry.
Yeah, it's Acconeer. Hello, so I'm Magnus here.
Hey, welcome to
Anna here as well.
Hi.
Welcome to you both. So why don't you introduce yourselves and talk about your company and what we have going on for CES 2021?
Absolutely. So I'm Magnus Garvard. So I'm heading up sales and business development at Acconeer.
And I'm Anna Alrud, and I'm heading up the marketing and communication department.
So awesome. Acconeer is a Swedish company based from research in South Sweden. And what we're doing is 60 gigahertz radar. So actually it's the most power efficient radar in the world. So I have it on the tip of my finger here. So it's extremely small, 5 times 5 millimeter BGA package. And well, the cool thing is that this is a complete radar system. So you have the antennas are integrated into the substrate, and you have the analog part and digital part, everything in one package, BGA package.
So is that using millimeter wave technology?
Right. So this is 60 gigahertz frequency band, which is an open band. Yeah. But the very unique thing, of course, this is small and neat and so on, and cost efficient. But the very unique thing is that this is a pulsed system. So we have a very unique innovation where we are sending out pulses, and it's coherent. So we know when we are sending out those picosecond pulses, we know where we are in the phase domain, and we can compare the outgoing wave pulses with incoming and still be very accurate. So we have a very accurate, precise system. And then with the pulse system, we can go down in power consumption. So in between the pulses, we're shutting down the sender and the receiver. So that means that we basically, I mean, even if we're sending continuously 100 hertz, it's less than 1% of the time that we're active. And that, of course, reduces the power consumption drastically.
So what are you using this for range detection? What is the commercial application on this?
Yeah. That's a very good question. So when we started this, we knew that we had a breakthrough technology. And the question was, of course, I mean, what should you use this for? And this was fully qualified, released about 2 years ago, 2018. And I mean, we have evaluation kits that we are providing through DidiKey. And now we see customers in many different segments using it for distance measurements. It's very sensitive. It bounces on skin, so you can use it for people presence detection.
Wow.
We have level measurements.
And also in robotics, some of our customers put it in moving robots to detect obstacles or things to avoid when driving around.
Yeah.
This really fascinates me. My prior background, I worked a lot in radar technology. I worked in the RF spectrum while I was in the military on lots of things. So when I see something like this that is in the millimeter wave, you really get my interest up in a big way, and especially in the form factor. That is an incredibly small. That's smaller than a dice. What is the actual millimeter size of that sensor?
It's 5.5 times 5.2 millimeter, and then only 0.88 millimeter high.
That's crazy. So I'm sure you probably have gotten some DoD type of interest in this as well. I don't know if you can say that or not, but to me, it's like, wow, very, very cool. So what is the range then, the effective range on that? Is it 10 feet, 20 feet? What's the range?
Yeah, it depends very much on the use case and what kind of objects you're looking at. Well, if you have a very good reflector like water surface, many customers are using it for water level. Mm-hmm. Water is a good reflector, it's flat. Then you can go up to 10 meter. Not sure what that is in feet, but
right. About 30 feet. Yeah.
yeah. So that works. But I would say that most of the use cases that customers are using it is for short range, so it's within 2 meters and so it depends a little bit. For example, you have people presence detection, people walking into room. That's about 4 to 5 meters.
And it's so small.
Yeah.
But then again, when it's probably put in an application, though, you're going to have some packaging, obviously, that's going to go around it. So the sensor itself is one thing, but the packaging is going to be a whole different. What are you seeing in a packaging standpoint?
Yeah, so that of course, I mean, you have to put some surroundings, etc. But it's pretty, since it's a complete radar system, you don't need antennas; they are integrated. You need a power supply. You need a clock reference. That's pretty small, and then you need an external host to process the data. And that's basically it's a SPI interface between the sensor and the host. So we are actually doing, many customers are taking the sensor and do the integration, hardware and software, but we also have some modules where we have done pre-integration. So we have example here is one module with one sensor on one side, and we have a Cortex M7 on the back side. So it's also pretty small.
It's really small,
and you can do different form factors. Here
we can maybe also mention that we're working on a project that's ready soon, where we build it into in-ear headphones for gesture control. So that's a tiny form factor that we managed to put it inside together with the 2 partner companies.
Yeah, that was actually, it came from last CES. We did a demo with over-ear headphones and gesture control. And the feedback we got was that, okay, this looks good, but it will be even more interesting if you can actually put that into in-ear headphones.
So what is the application with it for in-ear? I don't maybe fully understand what the application would be for that.
Yeah. So the radar data is processed by AI that our partner Imagimob developed, and then it's used for gesture control. So because the radar is so sensitive, it can detect small motions, and then you can pause and play the music and swipe to the next song.
And this is pretty using in-ears. It's pretty complicated with UI because you don't have. It's hard to find the buttons and so on. So if you can find an intuitive way of doing gestures, it's pretty smooth. And also with the radar, you can do it with gloves on. So you can do it outdoors. It's robust for weather and so on. So I think that's an application that is very interesting, and we're putting quite a lot of work into it.
Yeah.
So.
Yeah, this is the first I've been exposed to basically this size of a sensor, and I think I'm pretty shocked. I really am. Is it are you guys like leading the space in this?
Yeah, like I said, this is probably the smallest I've seen when it comes to radar. Still, the innovation is the low power consumption. And I think the really interesting thing is the combination here to provide a small sensor with very high precision and low power consumption, because then you can bring it into advanced consumer products like the headphones or other type of.
One of our hosts just said in the chat that this would be a great device to make assistive glasses for the blind to avoid obstacles.
That's a good one. Yeah. That is a good one.
So the company is called, and pronounce the company again, and I'm going to put it up on the. It's Acconeer, or is that the right?
Yeah, that's right.
All right. So, some of you are going to completely geek out here, and you need to go over to acconeer.com. And again, this is a radar sensor. So just so everyone is clear, you think about radar, you think about these big things on the side at airports that go in circles. But now radars have gotten to the point where at least some of the stuff I saw was on a pizza box. It just is a flat array with millimeter wave on a pizza box, similar type. But to put something that fits on the tip of your pinky, that to me just blows me away. So best of luck to you folks on this. And I'm sure there's going to be some companies out there going to see this and say, hey, we need to get connected up with them. And obviously you're doing mostly B2B at this time, but wow, this is impressive, really is. And for those of you that don't understand the dynamics on this, I'm telling you, this is impressive.
Thank you.
Thank you. And of course, everybody that are interested are welcome to get in touch with us. So
yeah, thank you for taking the time out of your schedule and the time. Of course, it's late there for giving us the demo here, and best of luck here for CES 2021. And we hope to see you in person in 2022, because I want to touch this thing.
Yeah, absolutely.
Thanks a lot.
Right. Great talking
Thank
to you.
Thank you for having us.
Thank you.
All right, bye.
Okay.
I hope you enjoyed that interview, and if you did, make sure you check out some of the more than 100 interviews we conducted during the virtual CES 2021 coverage. And of course, subscribe here on YouTube, hit the notification bell to learn when we post new content and when we go live.